Okay, then I think we have the last presentation for this session. It's entitled Observing Echo Model versus Tidal Gauges Around Hurricane Maria. The team consists of Frank Porches, Hannah Krohn, and Veit Hunja, and they were mentored by Fabrizio Velasca. Please take it away. Excited to see this.
Awesome. All right, can everyone hear and see the screen? I'm gonna go in between stuff, so you'll have to witness a few tabs. Apologies. Welcome, or hi everyone. Thanks for bearing with us to the end. My name is Hannah Krohn, and Faith will be presenting with us. Unfortunately, Frank couldn't make it today, depending on what time zone you're in. But today we'll be talking about the estimating climate and circulation of the ocean model, which is the NASA-based model we worked with for Climatematch, and the NOAA-operated tidal gauges that we were originally presented with the University of Hawaii Sea Level Center climate data. And so we basically took a version of the project we originally did and kind of very much isolated it and honed in on one specific project. So you can see here, this is the visualizer tool for ECCO, and this is the model that I think most people can look at for estimating quite a variety of factors. I'm going to go over here, and if you can see that it's September 1992. So later we're going to be talking about Hurricane Maria and the importance of understanding anomalous sea storm events and better understanding how they can be predicted, modeled, observed, either by satellites or in situ data. So just briefly, we'll go through here and see some anomalous data. ECCO is kind of the gold standard of what is a global sea surface model. And this estimates quite a variety of things. So as you can see, the anomalous sea surface heights increases over time in the Caribbean in the path of Maria, which we'll see later. So the idea that this was an area of study we wanted to focus on was because Maria was one of the strongest hurricanes ever recorded. It was the third, it was the third most expensive hurricane ever in the US history. And it is a representative of small islands and developing states. It is part of the US, but as one of the geographically similar regions to the largest collective by number regions in the UNFCCC, we thought it was worthwhile exploring. Maria was a Cape Verde hurricane that occurred in 2017 from October 16th to or from September 16th to October 2nd. It devastated Puerto Rico at a high-end category 4. So as you can see right here, it reached its maximum intensity of 908 millibars around 3 o'clock in the morning UTC time on September 20th, and with a peak intensity of 150 knots. The idea of it really developing very quickly along this in a north by northwesterly track and then kind of losing and dissipating over the course has an impact for how we observe tidal gauges recording this data, which basically led to our research question of how can we, account for tidal gauge data being disparate from models and satellite data, which while we know is there's a lot of different factors, which we'll discuss later. We wanted to see if we could put a number to the divergence. So, and I'll get to that later, but this is just another indication of why we were interested in this Caribbean Sea area. ECCO has been in development since 1992 to 2017. And so from this area, which is the Caribbean Ocean, we can see that there is indeed an increase in temperature and sea surface height. So we know that sea level rise is happening. We know that hurricanes are occurring in warmer waters, potentially more intensely, potentially more frequently, maybe not more frequently. I think that's still up for further research, but either way, there are more conditions to create more intense hurricanes, which we saw in 2017. So we took to compare the tidal gauge and ECCO data. I'm sorry if my headphones go out. It seems like they might be. No, it's okay. Sorry. We looked at the NOAA Center for Operational and Oceanographic Products and Services. Sorry. And obviously there were some that were taken out by the hurricane. In general, though, we found that this data was able to capture the extent of the variability in the amplitude that was necessary for understanding how much the sea surface height around the island was changing. So we looked at these 5 tidal gauges. This is an example of what one looks like in Esperanza and this island off the eastern coast. And then in general, ECCO grid sizes can be a variety of sizes, but for the modeling, it's a 1/2 by 1/2 degree latitude. So now Faith will take it away and talk about the actual data that went into Maria.
Okay, thanks. So our initial analysis involved comparing the relationship between ECCO and the tidal gauge data during Hurricane Maria. And we computed the normalized time series analysis for the tidal gauge data and ECCO data a month before Hurricane Maria, during the dates of Hurricane Maria, and a month after Hurricane Maria. And you can see the pink line shows the peak of Hurricane Maria. And so the observations we made based on our analysis was that, first of all, ECCO does not necessarily capture short time scales, which take the tides into account. So the tidal gauge sea surface height data measured from tidal gauges does that better. And there's also the absence of in situ data. So sometimes during extreme weather events, tidal gauges get destroyed. So we can only rely on we can rely on ECCO data, since it is more reliable in such cases. And also there is a lack of correlation of the ECCO data during extreme weather events. So for example, here we can see that ECCO remains mostly smooth throughout the entire time series. However, there's a lot of variability in the amplitude of the SSH data shown by the tidal gauges.
And that's noted by the dotted line and full line.
Okay, so next we're going to look at the, okay, so now based on our initial analysis, we thought that it would be wise to compare the time series analysis for the entire tidal gauge data. So here we did the time series analysis of sea surface height data, showing the intersection between the tidal gauge data and the ECCO model for all the tidal gauges that were involved in Hurricane Maria. And so from the graphs, you can see, for example, some tidal gauges were destroyed during the storm, for example, Fajardo. And from then on, we can only rely on the data from ECCO. And we also see, while ECCO remains relatively smooth throughout the time series, there's a lot of variability in the amplitude of the tidal gauge data. Next slide, please. And so to further compress the data and to smoothen the temporal coarseness of the SSH data, we decided to compute a rolling mean. So both the tidal gauge data and the ECCO time series were put through a 1,000 hour rolling window to compute the mean. And we also did the Pearson correlation coefficient to see how the means compare between the tidal gauge and the ECCO model. And the red line you can see is when Hurricane Maria started. And so we see that the values from the Pearson correlation coefficient, we see that the values are close to 1, which show seemingly positive correlation compared to the others. Next slide, please. And we also computed the standard deviation still over 1,000 hour rolling windows, and we see very low standard deviation values. This shows that there's very low variation in the sea surface height data in the respective data for the respective data sources, and we also see that the data is relatively close to the mean. However, we see some low correlation when we compare compare the standard deviation between the tidal gauge and the ECCO model. So the conclusions we made from our analysis were that first of all, in situ data can be unreliable during extreme weather events since the tidal gauges can be destroyed. However, they seem to be more accurate over short timescales in showing the SSH data compared to the ECCO model. And over long time scales, ECCO is very reliable, but it doesn't account for extreme weather events. Next slide, please. A couple of things that our analysis did not account for, which we might want to explore in the future, were the extent of the sea level rise impact on other ocean physics, the tidal gauge calibration cycle, and the hurricane turbidity compared to the tidal gauge data.
So that's in comparison to the limitations of our work. We can also see other forms of statistical analysis, and if anyone has any other thoughts, we'd love to hear how to compare this to other storm events, especially given the nature of it being in the Caribbean Sea. Our previous research tried to have storm data that was involved with neap tides and other such of like high and low comparisons. We didn't get to explore that here, so we realized this is just a one-off. And hopefully this work can advocate for the idea that more tidal gauges should be created and maintained for long-term reliability, as in conjunction with ECCO development and other sorts of satellite stuff. Thank you so much, especially to this team in front of us and our advisors and reviewers.
Thank you so much. Any questions? Oh, sorry, I missed. Sorry, my window is too small.
Oh, we have one hand, I think.
Natalie.
Thank you very much. Super interesting. I'm not an expert in this, but did it look on the ECCO data as if they just didn't detect the hurricane at all? Or was I missing some nuance there? And the data you first showed, I think it's your third slide or something. Yeah, this one. Here it looked as if you just couldn't detect the data at all on the ECCO data. Did I miss something, or is that really true?
That's what we saw. So,
and is that
again,
is that mainly because of the bin size of 0.5 degree, or is that something, yeah, more connected to the ECCO kind of data you recorded?
I think, I don't know if you're muted. I can't hear you.
But I can't hear anything. I'm not sure if others.
I can't hear you there.
Maybe I can follow up with like a question, since you mentioned satellites. Have you looked at some of the satellite sea surface height products? I mean, I think like ECCO is the limitations of like resolution alone are probably fairly heavy. Like it's like tidal gauges are like very small compared to ECCO state estimate, but I was wondering if there's sort of other remote sensing data that could have more of a sort of spatial coverage that you have considered for this.
Okay, so far we only looked at ECCO, since that's what we started with, like during Climatematch Academy, like during our initial project analysis. So yeah, aside from ECCO and the tidal gauge data from NOAA, we didn't look at any other sources.
Oh.
And also because the ECCO dataset it runs from 1997, I think, till 2017. So we found that like we could get data over a long time period. So yeah, that's what we decided to settle on.
Yeah, I'll ask a question too. Maybe, yeah, I was just wondering, so you said the resolution of the ECCO model was, I think, half a degree. What about, what was the temporal resolution of the model output? Is it hourly?
Yes, I should think so.
Hourly. Okay.
I think it's still like it's worth just being careful with that, because I think there's like ECCO has probably, due to the resolution, like if you have, like, you can sort of resolve as much time scales as you want. If you don't have the spatial resolution, you will, like, particularly when you're comparing variability, it might just be a limitation of the state estimate itself. And that's why I think like some intermediate product, or maybe as a suggestion, I'm not sure if they actually resolve sea surface height, something like a forecast model that runs on like shorter range, not for decades, but like might have a higher resolution. I'm thinking of like, but actually maybe I'm thinking wrong here. I think there's like a lot of the hurricane forecast models actually only run the atmosphere, so maybe that was a red herring. But yeah, I think like some intermediate product to sort of tie that together might be a really nice next step.
Okay.
I think we still can't hear Hannah. Yeah, if there's no additional questions, I think then we can congratulate all the speakers again and have a round of applause. Thank you, everyone. And yeah, I'll hand it to Courtney and Natalie to see what how the next part of the session will be structured.